Here we go, geometry 1-3, measuring segments. The object here is to find and compare lengths of segments. So, like normal, we'll start out with some vocabulary. A coordinate is just simply the number that corresponds to a point. Distance is the absolute value of the difference of the coordinates for those 2 points. You'll understand that more when we do it. Congruent segments have the same length, in other words, they're equal. A midpoint is indeed a point that divides a segment into 2 congruent or equal segments. A segment bisector also divides a segment into 2 equal parts, 2 equal segments. A bisector can be a point, a line, a ray, or another segment. So let's put some of this to practical use and go on to the next page. Here's a postulate. What's a postulate? Right, an accepted rule that you don't have to prove. By the way, you don't have to remember these numbers 1-5. You just have to remember, like, it's the ruler postulate. So the ruler postulate says every point on a line can be paired with one real number. So how would we use that? Well, let's suppose we have a question. What is ST? In other words, the measurement from S to T. Well, S is -4. And T is 8, so -4 minus 8, we're taking the difference between the 2 numbers. -4 minus 8 is -12, the absolute value of that is 12. Okay, so you try one. What are UV and SV on the number line? Okay, well, okay, try 2. What are UV and what's SV? Well, if you said UV is 10 minus 14, absolute value, or 14 minus 10, UV is 4. Ta-da, you're right. So if you said SV, -4 and 14, and you took the difference of those and you got 10, you're wrong. Because the difference of those is 18. How does that work? It works like this. Let's take this off here. 14 minus a -4 is really +4. Minus a negative is really plus. So 14 plus 4, 18. Got it? Moving on. Let's talk about another postulate. Segment addition postulate. That just says if you're adding 2 segments together, if 3 points, A, B, C, are collinear, they're all on the same line, and B is between the 2, A and C, so you got A, B, and B, C, then you can add those up. You can do AB plus BC. You add those together, and they become AC. Get it? You can add this one and add this one, and together they become the length of the other one. Seems easy, right? So let's do the algebra of that. So suppose you got a question like, if EG, from here to here, equals 59, this distance equals 59, then what are E and F and G? E and F and F and G, what are those distances? Well, here's what we do to solve that. We take what we know to find out what we don't know. We know that EG, this distance, is 59. And we know that EF, this distance, is x minus 14. And we know that FG, this distance over here, is 4x plus 1. So what we can do is take EF plus FG, EF, this distance, plus this distance, FG, will equal the whole distance, EG, by the segment addition postulate. So now we're going to substitute EF plus FG. Oops. Substituting that there. Now it's better. So now we can combine like terms. 8x and 4x is 12x. Negative 14 plus 1 is negative 13. Add 13 to both sides. 13 here, whatever you do to one side, you do to the other side. Isolating that variable and getting rid of the negative 13. Remember those old algebra tricks? So 12x comes down. 59 plus 13 becomes 72. Negative 13, positive 13 cancel each other out. So we divide both sides by 12, and we get x equals 6. Ta-da! Done? Nope. Because the question was, what was the length of EF and the length of FG? So here's what we do. We use this value of x to find out those lengths by substituting 6 for the x. Remember, EF is 8 minus 14. So we'll substitute 6 in for x. And remember, FG was 4x plus 1. So we'll substitute 6 in there. And let me get rid of this entirely. Substituting 6, 8 times 6 is 48. Bring down the minus 14, and EF equals 34. 4 times 6 is 24, plus 1 is 25. Now, ta-da! We have the answer to the real question. EF is 34, and FG is 25. Using algebra, and using what we know to find out what we don't know. Moving on. Now let's talk about congruent segments. By the way, this is a sign for congruent, a little squiggly line over the top of an equal sign. So you might write line AB is congruent to line segment, that is, line segment CD. No arrows on the ends, so they're not lines, they're just segments. And here's how it would look. If the measurement for AB and CD were the same, like suppose these both measured 1 inch, then the measurement would equal each other. So therefore, we would say that segment AB is congruent to segment CD. And the way we signify that is by putting a slash mark in those lines, just like that. Now suppose we have a question. Are segment AC and BD congruent? Well, let's see. Segment AC is this section right here, and segment BD is that segment right here. Are they congruent? Well, this is how we technically find out. You may be looking at that and going, yeah, they're the same length, looks like it, because I can count the little spots. But what if you didn't draw the number line? What if you just had the numbers? So the definition of distance, -2 minus 5, and the absolute value of that is 7. And this one looks like it's 3 minus 10. Absolute value of that is also 7, so ta-da, yes, they are congruent. The measurements are the same, so therefore the segments are congruent. Moving on. Last thing we're going to talk about in this video is midpoint or segment bisectors. If B is the midpoint in AC, then right there B is on line L, so line L is a segment bisector. By the way, so is point B a segment bisector. Point B gets 2 names. It can be called the midpoint, or it can be called the segment bisector. And we put little slash marks saying this side equals this side. If you have the same number of little slash marks, that means that they're equal. Doesn't matter if you use 1 or 2 or 3, but they got to have the same amount saying, yep, those are the same measurement. So let's do some algebra. Let's say Q is the midpoint of line segment PR. So what is PQ, and what is QR, and what is PR? Wait, before we were given the measurement of PR. That's all right, we can still do it, because it says that Q is the midpoint. That means this one equals this one. So we just set them up. PQ equals QR. So the measurement of 6x minus 7 equals the measurement of 5x plus 1. We're substituting those measurements for the segments. So we'll take away 5x from both sides, and we get x. We'll add 7 to both sides, equals 8. So therefore, ta-da, x is 8. But remember, we're using what we know to find out what we don't know. So we're taking 8, substituting it in for x, into each one of those little expressions. So 6 times 8 is 48, minus 7 is 41. And we expected them to be the same, but we'll double check. Putting 8 into this one, 5 times 8 is 40, plus 1 is 41. doubling the two segments, then the whole big one is PR. Ta-da! Done. Got it? See you in class.